Good morning, ma'am. I'm Venala. I'm from CSC Department of AML. My roll number is 25955586626. Today's computer networks that my topic is link layer protocols. Introduction to the link layer. The link layer is the second layer in the OSI model responsible for node-to-node data transfer across a physical link. It handles framing, physical addressing, error detection, flow control, and medium access control. This layer ensures reliable communication between directly connected devices like switches, routers, or hosts. Link layer protocols operate on both wired and wireless media, adapting to different transmission characteristics. Understanding this layer is essential for designing efficient and robust network systems. The link layer is the second layer in the OSI model that is responsible for the node-to-node data transfer across the physical link, and it can handle the error detection, flow control, and medium access control, and it ensures the reliable communication. And the link layer protocols operate on both the wireless and wired media. Next, we can go through this. Services provided by the link layer. Framing divides the bit stream into manageable units called frames for transmission. Physical addressing adds source and destination MAC addresses to frames for local delivery. Error detection uses techniques like CRC to identify corrupted frames during the transmission. That the link layer can provide the error detection that is used to identify the corrupted frames that during the transmission of data from one node to another node. And the flow control manages data rate between sender and receiver to prevent buffer overflow. Medium access control coordinates access to shared communication channels in the broadcast networks. This is the services that the link layer provides. And next, framing techniques. Framing marks the beginning and end of a frame to help receivers parse into the data correctly. And byte count uses a field in the header to specify the number of bytes in the frame. Flag bytes with byte stuffing uses special delimiter bytes and escape sequences to avoid ambiguity. And the start and end flags with bit stuffing insert extra bits to distinguish control patterns from data. The physical layer coding violations exploit signal encoding rules to mark frame boundaries. These are the framing techniques of the link layer that the framing marks the beginning and end frame or to help receivers parse into the data correctly. And the byte count that uses to specify the header, the number of bytes, and the start and end flags with the stuffing that insert the extra bits that use to distinguish control pattern from data. And error detection methods of the link layer that error detection identifies corrupted bits caused by noise or interference during the transmission, and parity checks and a single bit to detect odd numbers of bit errors in a block of data. Checksums compute a simple sum of data bytes and append it for verification. Cyclic redundancy check that CRC that uses polynomial division to generate a robust checksum. And the CRC is widely used in Ethernet and the other protocols due to its high detection capability. The cyclic redundancy check that uses the polynomial division and that used to generate a robust checksum, and the checksums compute a simple sum of data, and the CRC is widely used in the Ethernet and other protocols that it has the high detection capability and error detection identified corrupted. It's because the caused by noise or interference that during the data transfer from one node to another. And the flow control mechanisms. The flow control mechanisms, the flow control prevents fast senders from overwhelming slow receivers by the registered data flow. And the stop and wait sends one frame at a time and waits for an acknowledgement before sending the next. Sliding window allows multiple frames to be in transit, improving efficiency over stop and wait. and the window size determines how many frames can be sent without acknowledgement. The go back and selective repeat are two common sliding windows protocols with different retransmission strategies. The go back and selective repeats that it has the common sliding windows and it has the protocols with the different retransmission data strategies, and the flow control prevents past senders from overwhelming, and the stop and wait sends one frame at a time and waits for acknowledgement before sending the next. This is the flow control mechanisms of the link layer. And the stop and wait protocol. Stop and wait transmits one frame and waits for an ACK before sending the data. And if no ACK arrives within a timeout period, the sender retransmits the frame. Simple to implement but inefficient for high latency or high bandwidth links. And the sequence numbers alternate between 0 and 1 to detect duplicate frames. And these can be used in early protocols like X modem and still relevant in low speed or educational context. The stop and wait protocol in the link layer is used to transmit the data from one frame to another frame and waits for an ACK that before sending the data to another. And if the ACK not arrives within a timeout period, the sender will retransmit the frames. And it is simple to implement, but it is inefficient for the high latency or high bandwidth links. And the sequence numbers of the stop and wait protocol is lies between the 0 and 1 that detect the duplicate frames. And next, sliding window protocol. The sliding window improves throughput by allowing multiple acknowledged data in transit. The sender maintains a window of frames that can be sent without waiting for ACKs, and the go back and retransmit all frames from the last one onward when an error occurs. Selective repeat retransmits only the missing frame, requiring more complex buffering. Both protocols use sequence numbers and timers to manage reliability and ordering. These are the sliding window protocols of the link layer that improves the throughput by allowing the multiple acknowledged data, and the sender maintains a window of per frame, and the selective repeat retransmits only the missing frame, and the both protocols use sequence numbers and the timers to manage reliability and ordering of the sliding window. And next, medium access control, the MAC. MAC protocol manage how devices share a common communication change broadcast networks, and the controlled access protocols like token ring grant permission rights in a predefined order. The random access protocols like Aloha and CSMA allow devices to transmit when ready or risking collisions. The CSMA or CD detects collisions in wide Ethernet and triggers retransmission after a backup period. And the CSMA or CA avoids collisions in wireless networks by using acknowledgements and a deferral mechanism. This is a medium access control that manage how devices share a common communication, and it can has the access protocol like token ring that grant permissions right in a predefined order, and it uses the random access protocols like Aloha and CSMA that devices that used to transmit when ready or risking collisions. And the CSMA or CA that can avoid the collisions in wireless networks by using the acknowledgements and deferral mechanisms. Ethernet and IEEE 802.3. Ethernet is the dominant wide LAN local area network technology standardized under IEEE, and it uses CSMA or CD for collision detection in half duplex mode. Through modern Ethernet is full duplex. Frames include programmable destination and source MAC addresses, type or length, feed, payload, and CRC. MAC addresses are 48-bit identifiers burned into network interface cards for local delivery. Switches learn MAC addresses to forward frames only to the intended port, improving efficiency. Wireless LANs and IEEE. This is the IEEE 802.11 that defines wireless LAN standards, commonly known as Wi-Fi, and it uses CSMA or CA to avoid collisions since wireless signals can't detect that. Frames include MAC headers with source, destination, and BSSID addresses for routing over air. And the RTS CTS handshake reserves the channel before data transmission to reduce hidden node problems. Point-to-point protocols. That point-to-point is used for direct connections between two nodes such as dial-up or dial links. It supports multiple network layer protocols and provides authentication via PAP or CHAP. The point-to-point protocols names include flags, address, control protocol, payload, and CRC field. The network control protocol configures different network layer protocols like Internet Protocol. The virtual circuits and diagrams. Link layer can offer connection-oriented or connectionless oriented services, and the Ethernet uses datagram service, while ATM historically used virtual circuit. And choice depends on application needs for reliability, ordering, and overhead. This is the virtual circuits and datagrams that datagram service treats each frame independently with no prior setup or state maintenance. In the summary and key takeaways, the link layer ensures reliable communication between adjacent networks, and the core functions include framing, addressing, error detection, flow control, and medium access. Protocols like Ethernet, Wi-Fi, and PVP implement these services for different environments. Link layer design impacts overall network performance, scalability, and reliability. Thank you.